So finally, let's look at the optimization methodology that was implemented to improve the performance of the baseline design. And so as you can see in this table, for the 10 parameters that were selected from the sensitivity study, the ranges were shifted up or down by 25% according to the sign of the sensitivity. And then for the remaining 10 parameters, if the sensitivity was positive, then the perturbed value of the parameter was used instead of the reference design value. And then this table shows you the new ranges and values of all the design parameters that were selected for the optimization. Next, for the design of experiments, 50 designs were generated using optimal space-filling latent hypercube sampling, of which 7 failed to measure convergent CFD. And then a Kriging type response surface was fitted to the data of the 43 successful designs, after which MOGA was used to search the design space and generate a Pareto front for the given objectives and constraints, where the objectives were to maximize the efficiencies at 2 points that are 90 and 105% of design flow rate. And note that the pressure ratio was not really set as a constraint since its variation was seen to be very small in the DOE. And here you can see the Pareto front showing the trade-offs between the two efficiencies from which an optimal design was selected, and its performance was then validated by CFD simulation. And so these results here clearly confirm a very good accuracy of the Kriging RSM by comparing the predicted and CFD efficiency values of the optimal design at both the operating points. And in fact, this is what changed as a result of the optimization. So here you can see a comparison of the meridional geometries of the baseline design and the optimal design, where the major difference is that the axial length and the inducer height of the optimal impeller are increased, and also the return channel curvature is changed. And then here are also the changes to the blade loadings of the impeller, the diffuser vane, and the return channel vanes of the stage as a result of the optimization. And then finally, coming on to some numbers, you can see here this performance map comparison at the different flow rates, and the optimal design is clearly showing around 1 percentage point improvement in the total to total efficiency over a wide operating range, with the total pressure ratio still exceeding the target value of 2 at the design point. And furthermore, if we compare the flow fields at the design point, then the flow separation near the baseline impeller and diffuser shroud trailing edges is actually removed in the optimal design, which results in an improvement of the flow behavior in the crossover bend, as you can see in this area.